Thank you. It's great to be here. I'm a Solar System Ambassador, so volunteer for NASA to talk about some of the projects that we're working on. And has anybody heard of the comet of the decade that's supposed to show up later this year? Huh? What's it named? Comet Ison. Comet Ison was thought to be maybe the comet of the decade. Right now, we're not quite sure if it's going to be as bright as we thought it was going to be. But in honor of Comet Ison coming by in November this year, I thought I would talk about what NASA's done to research comets. Now, comets are some of the earliest material from the solar system that we think the planets were formed by. So if we can research comets and find more about what makes up the comet and how they operate, we think we can learn more about the early evolution of the solar system. So really, here's a picture of Comet Ison taken by the Hubble telescope last May. Comet Ison will be viewable in the early morning hours starting in November around Thanksgiving week. And it should be bright enough for you to go out early in the morning and see it. And if you stop by the astronomy section over here to the right, they could probably tell you a little bit more about how to view it. But you'll be hearing a lot in the news about Comet Ison. Well, what is a comet? It's a small, icy rock. It's made up of ice and dirt, and it displays an atmosphere and a tail as it gets close to the sun. Now, as I said, the nucleus is made out of rock and ice and dust, and they're typically pretty small. You can see a little diagram. You have a small nucleus of the comet, and then as it gets close to the sun, a coma forms. That's more of the atmosphere of the comet. As the ice escapes from under the crust, it forms that atmosphere, and then the solar wind of the sun blows that atmosphere out and creates that long tail that you see following the comet. Now, the nucleus of a comet is very dark. It's as bright as black tar, so it's really hard to see. And when we sent spacecraft, the first spacecraft we sent there couldn't image the comet very well, but we've developed cameras that can take pictures in that low light and give us some more details of the comet. But they're not very reflective. It's only when the ice starts escaping and it forms that coma and forms that tail that those comets become bright. Typically, comets are less than 40 miles in diameter. Most of the ones we visited are no more than a few miles in diameter. The comets originate in what they call the Kuiper Belt, which is a spot outside the orbit of Neptune and Uranus. Those are short-term comets. They come by every few hundred years. There's some long-period comets that visit us very infrequently, and they have orbits of hundreds, and if not thousands of years that go out to the Oort cloud. Now, there are about 5,000 comets that we know of, but there could be about 1 trillion comets altogether. We just haven't discovered them yet. We have encountered 7 comets with spacecraft so far, and that's what I'm going to talk today about. So I'll show you some of the pictures of the comets we visited. Now, the first spacecraft that we sent to a comet wasn't really supposed to go to a comet. It was the International Sun-Earth Explorer, and it was studying the sun. But after it had finished its work, one of the scientists of the project had decided that there was a way to actually send this out to a comet. So it didn't have cameras, but was able to measure some of the atmosphere around the comet, and it actually visited a comet named Giacobbe-Zinner in 1985. It then went on to visit Comet Halley, which is one of the most famous comets that we have, named after Halley there. Comet Halley was last seen in 1910, and this is actually a picture card from Gary, Indiana, showing a picture of what the comet would look like. We knew the Comet Halley comes every 76 years or so, and so we knew it was coming up in the 80s. In 1986, we'd be able to encounter Comet Halley. So everybody wanted to go visit Comet Halley, a famous comet. Now, countries sending spacecraft to Comet Halley were Japan, the Soviet Union, and Europe. But the United States didn't send a spacecraft to Halley. And I'll talk a little bit about why. One of the things, Comet Halley is in a highly eccentric orbit. So it orbits out of the plane of the other planets. So it's sort of hard to get to. It's steeply inclined to the ecliptic. It also goes retrograde. Its motion is opposite of the planets as they go around the sun. Those all add to the difficulty in reaching it. Also, back in 1986, if we were going to reach Comet Halley, we would pass it by about 37 miles per second, which would be really fast to be able to get some good information. We would have to use some untested technology to get out there, like an ion propulsion system or even a solar sail to use the pressure of the sun to get us there. And we hadn't really developed that technology yet, so the United States decided not to go visit Comet Halley. One of the stories that was told is that NASA went to the President Carter at the time, and made one last pitch to send a spacecraft to Halley. And he was reading a book about black holes at that time, and it was a choice between sending a spacecraft to Comet Halley or building the Compton Observatory. And he decided, since the Compton Observatory could view black holes, we would build that instead. So in any event, there was a fleet of spacecraft that went and visited Comet Halley. The Japanese sent Suzy and Sagachi to encounter Comet Halley. They weren't really meant to take very close pictures of it, but it took pictures of the hydrogen that escaped as that coma formed. Russia also sent a couple spacecraft called Vega 1 and Vega 2 to Halley. Now on its way, it also encountered Venus and dropped space probes onto the surface of Venus. And this is a picture from the surface of Venus from one of the probes that dropped down onto the surface on its way to Halley's Comet. So Vega 1 and Vega 2 were really the first spacecraft to get good images of Halley, and they weren't that great of images, because again, they were passing by about 32 miles per second. Here's a time lapse of that encounter. You can see the nucleus of Halley there. It's not very good images, but it allowed the next spacecraft called Giotto to be able to get better pictures. Now, Giotto was Europe's first spacecraft to a solar system body, and it was designed to withstand a close pass of the comet. It was going to travel within 300 miles of the nucleus, and it was going to be hit by a lot of particles from that comet being blown off by the sun. Now, Giotto was named after an Italian painter who painted the Adoration and the Magi and had a comet in the scene there. So that's why they named it Giotto. Giotto used something called a Whipple shield, which is layers of like Kelvar material to protect it from the hits as it got close to the comet, so it would be protected from getting hit by the particles. So Giotto got close to Halley. These are the pictures, some of the pictures of Halley's Comet. What they found was you had a rocky body with ice underneath the surface, and some small jets would escape as that ice escaped through cracks in the surface and helped form the coma and the tail. This is one of the most famous pictures of Halley's Comet that we have right now, pretty much the best picture from Giotto. But again, this was the 1986, this is early technology, this is the best we could do at that time, and Giotto actually got hit by a particle, even though it had that Whipple shield, its camera got knocked out, and it didn't get to take all the close-up pictures it was going to. But it was the first attempt to visit a comet, and we learned a lot from that. Now, NASA didn't give up, though. NASA developed a spacecraft called Deep Space One, and it tested some new technology that we didn't have when we wanted to go to Halley. Specifically, one of the things it tested was ion engines. Now, an ion engine is unlike a chemical rocket. A chemical rocket, you have a certain amount of fuel, you burn it, and you thrust, and then the thrust is over. An ion engine can produce small amount of thrust over a long period of time. The ion engine on Deep Space One could get you from 0 miles per hour on day 1 to 60 miles per hour on day 3. So it doesn't sound like a lot, but over time, if you're operating this engine for hundreds of days, you can keep speeding up so that you can encounter this comet at a slower speed and be able to get some more information. So that's one of the things that Deep Space One had on board. Deep Space One passed by Comet Borley. It was able to return some pictures. Comet Borley was a small comet, potato-shaped. Comets, again, small comets aren't massive enough to become round. So a lot of them are irregularly shaped. Now, NASA next sent a spacecraft called Stardust to encounter a comet. And what Stardust was going to do was put out a hand that had special compartments and special gels that would capture some of the material coming off of the comet and return it to Earth. So Stardust had this hand that had what they called aerogel in it to capture particles as it flew through the coma and the tail of Comet Wild 2. So Stardust sent us back this picture of Wild 2. And the collector actually landed safely on Earth. And when they got the aerogel open and they started looking at what it had captured, you could see where particles entered that aerogel and stopped. And they were able to go into that aerogel and pick out those particles and actually do experiments and learn a lot about what made up that comet from this material that it brought back to Earth. Now, the next mission to the comet was called Deep Impact. And what Deep Impact did was fly to a comet, and then it released a vehicle-sized probe to crash into the comet. And as it crashed into the comet, the rest of the spacecraft took pictures as it flew by and threw all that dust cloud up to measure what had happened. So it was launched in 2005. And it flew to Temple 1, Comet Temple 1. Now the next pictures I'm going to show you is when it released the probe, you're going to see it as it gets closer and closer and then crashes into Temple 1. Now the next set of pictures, you're going to see the main spacecraft passing by and watching this explosion. So you can see where it hit the comet, threw up the material, and then the spacecraft used sensors such as spectrometers to measure what got expelled from that crash. Now, interesting enough, the Stardust spacecraft, when it actually brought that material back to Earth, it was still in orbit, and it actually flew past Temple 1 after Deep Impact had hit. It sent back pictures of the crater that got created by throwing that penetrator or that vehicle into the comet. It also went on to view Comet Hartley, another potato-shaped comet. And you can see Temple 1 compared to Comet Hartley there, that's both visited by Deep Impact. Now, the last mission I want to talk about is a mission that's going on right now to actually orbit a comet. It's called the Rosetta mission. NASA's helping the European Space Agency with this. Rosetta was launched in 2006, and next year it is going to go into orbit around a comet. It's going to go into orbit, it's going to see that coma get created, it's then going to see the tail get created, but it's also carrying a lander called Philae, and the lander is going to land on the comet. It's going to drill into the comet, It's going to take soil samples, burn it to see what gases it gives up, to see what the makeup is, and then take pictures of the comet. Now, the Japanese tried sending a spacecraft like that with a lander to an asteroid a few years ago, and they threw the little lander out, and because asteroids and comets don't have much gravity, the lander just sort of bounced off and went into space. So Philae, the lander on Rosetta, actually is going to shoot a harpoon into the comet, wind itself back in to pull itself to the ground, and also on its landing legs, it's using like screws to screw into the comet's surface as it lands. And even if it starts to fall away even after that, if it starts to bounce off, it has a little thruster on top that'll thrust down and hold it down. So I have a short video that shows how this will work. It's happening next year, and they use a Lego. They built a model of the Philae lander out of Lego blocks. So believe me, it's not really made out of Lego blocks, but it's an interesting demonstration of this lander.
The comet chosen was Churyumov-Gerasimenko, a comet discovered by a pair of Ukrainians back in 1969. It orbits between the orbit of Jupiter and the orbit of Mars. The nucleus is roughly 4 kilometers across. We cannot say precisely what shape this is, but the small size means it cannot form a sphere under its own gravity, so it's likely to be roughly potato-shaped.
So again, the main spacecraft is going to go into orbit, but before it goes, and when it finds a good landing spot, it will eject Philae to actually land on the comet. See the drill bit drilling into the comet's surface. It'll take that soil into an oven and bake it and measure the materials that are coming out. And here they're using the Lego to talk about how it will attach itself to the comet.
Fixation is a very important issue on the comet surface as there is low gravity. As soon as 2 legs have contact to the comet surface, a harpoon gets shot, which you can see over here. This harpoon is taking a small wire with it, and as soon as the anchoring tip is fixed in the comet surface, the wire gets rewinded and the lander rests perfectly on the comet surface. In addition to this fixation, in the foot itself there is a so-called eye screw, which uses the landing energy to screw into the surface and therefore is an additional fixation. On top of that, as all these means are not working at all, we can use our so-called cold gas system, which is a kind of hold-down thrust. Means there is a thruster which can blow out a force to keep the lander on the comet surface until the damping mechanism of the landing gear is able to get quit of the descent velocity. The landing gear has a few more functionalities. There is a rotation mechanism. The overall body can be rotated around its axis to make measurements on different surface spots. It can lower and lift the complete lander down to the comet surface, and it can tilt as well the body of the lander so that the bottom plate of the lander is nicely parallel to the comet surface.
So we're hopeful that with the Rosetta mission we'll learn a lot more about comets, being able to orbit the comet, watch that coma develop, watch that tail develop, Philae actually landing on the comet, sending us back measurements and pictures of the comet, So you say, well, what else is there to learn? What is there else to learn about comets? Well, the next mission we're thinking about is a sample return actually from the comet. So we sent stardust there, and it got particles ejected from the comet, but what if you could get a core sample from the comet, like drill in, bring out a core sample, and bring that whole core sample intact back to Earth? Well, the thought is we would send a spacecraft to go into orbit around a comet, not during the time that the coma is developing or the tail, and actually send a harpoon or a penetrator out to the comet that'll go deep into the comet's surface, get that core sample, and then reel it back into the spacecraft. So the spacecraft wouldn't actually land on the comet, but bring that core back into the body of the spacecraft, and then using an Eon engine, breaking out of orbit and coming back to Earth, bringing that core sample into a landing capsule and sending it back to Earth. So that's what we're looking at to do in the next few years. Other than that, the next return of Halley in a few years, there's talk of maybe even sending a spacecraft out to join Halley, maybe towards the Jupiter orbit, and to orbit Halley as it forms its coma and as it forms its tail, and have a really good look at Halley this time, because now we have a little better technology to actually go there and visit and learn more about it. So thank you for your time today, listening about comets. I'm over at the table there. If you have any questions, I'd be happy to answer them for you. Thanks.